So I think we can start. And today um, we are going to learn about using a circuit simulation software that is called LT Spice. So LT Spice is a powerful free spice-based circuit simulation software that is widely used for simulating, analyzing, and verifying electronic circuits, particularly for analog and power electronic applications. So that is to say that when you want to build a circuit, usually it's good practice to simulate its behavior in a computer before you can take the components, assemble, and test. Because if your design is not correct and you go ahead and build the circuit before simulating, then you end up wasting a lot of your time, incurring cost, and that could have been prevented if you and simulated the circuit behavior before building a prototype, a physical prototype. And so that underscores the importance of simulating circuit behavior before you can construct the actual physical circuit. And for that, for simulating circuits, we will be using this LT Spice software. It's a free software that you can download. And I want to believe you have downloaded this software. If you haven't, you just need to search for LT Spice software and download. And you should be able to get the appropriate link and download the software and install it. So I hope you have done that so far. And so what we will be doing today is demonstrating how you can use LT Spice to do circuit simulation. And the circuit simulation I have in mind is a circuit we refer to as a rectifier circuit. Now, if you can recall, what is a rectifier circuit? A rectifier circuit is a circuit used for converting AC voltage or current to DC current and voltage. Usually that circuit is very important because the mains electricity is in form of AC power, but most of the electronic devices usually are powered using DC power. And so you need now to convert AC to DC. And the circuit you use for that conversion is what we refer to as the half-wave rectifier. Of course, you should have discussed this in your previous electronic courses, but just as a review, a rectifier circuit, of course, there are two types of rectifier circuit. There is what we call half-wave rectifier, which comprises of a single diode. Now, from your basic electronics, you know a diode is a device that allows current to flow only in one direction and would block current from flowing in the opposite direction. And so if you take AC voltage and pass it through a diode, as shown in this first diagram, then connect your load. For this discussion, let's assume it's a resistor as shown, and back to so that you build a circuit like this. Then you have what we call a half wave rectifier. How does it work? It works this way. When the AC signal is executing its positive half cycle, like shown in this input waveform, then what happens is the diode is forward biased because the anode is more positive than the cathode. And therefore current flows through the diode. And when current flows through the diode, it now flows through the resistor. When current flows through a resistor, a voltage is developed. And therefore you can see the output voltage waveform across that resistor as a result of the positive half waveform in the input. Now, during when the input voltage becomes negative, what happens is that the diode is reverse biased. And when the diode is reverse biased, no current flows through it. And therefore, no voltage is developed through the road resistor. And so if you look at several input cycles, the output is as shown in figure C, whereby at some point you have voltage waveform, and at some other point, no current flows, therefore the voltage is zero. And so you end up with a waveform like that. So this is a circuit that we refer to as a half-wave rectifier. So let's say you wanted to build a half-wave rectifier, and the first thing you want to do is to simulate your circuit so that you can see whether it will work or not. So when you simulate, you are able to observe or measure voltages at different points, or if it is monitoring the waveforms, both current and voltage waveforms, you can be able to generate those waveforms in your simulation circuit. And so we will start by designing a circuit like that, and we simulate its behavior. So if what I would want to believe is you have your laptop with you, and so you will try to do what I will be doing. So what I will do is I'll stop sharing the screen, and I will start sharing a different screen. I want to look for the LT Spice screen. I don't know whether you can see the new screen. Anyone who can talk, you can see the LT window on your screen. So I don't know why you are not able to talk. You can unmute yourself and say whether you can see the screen.
Yeah, we are seeing it.
Okay. So I've just opened, so let me start a new screen. So just a minute, just a minute. I want to open. So when you open LT Spice and there's assuming you have downloaded the the latest version. So when you launch that software, this is the first screen you get. So that's the first screen you get. Um, so this screen has a number of icons. So someone is talking, and when I say you respond or not. Okay, so this is the screen you get once you launch your Open Spice, your LT Spice. Just to mention a few icons. So if you want to build your circuit, you can see a number of components. Of course, like if you can see my cursor, I am hovering at the resistor symbol. Then you have the capacitor symbol here. You have an inductor. You have an diode. You have other components. You can choose other components here. So to start simulating, you come to the new, then new schematic, and there you have a window where you can build your circuit from. So let me maximize this. So now I am set to start building or designing my circuit. And the circuit that I'm building is a rectifier, is a half-wave rectifier. So a half-wave rectifier, I will need a diode. So I come, pick a diode here and place it. Okay. So to escape from the diode, I have to place escape. And I should now go and pick another thing. Now, I need to say maybe the best way to place this diode is not vertically, but horizontally. So to rotate it, I place Control R. Sorry, let me Control R. So just let me repeat that. So I Control R. So now it's in the right orientation. So I drop it and escape. The next thing I want to pick is my voltage source, but my voltage source is a AC voltage source. So where do I get my voltage source? Is at this icon. So when I hover over it, I get voltage source. So I pick it and come and drop it. Then escape. Next, so the next thing I want to do is, of course, put my road resistor, pick it from the resistor symbol and drop it. The next thing I need to do is join now with the wire. So join with the wire. So the wire is here. So pick the wire. It comes as a crossbar. So I start maybe at this point. So you can see the cross line. So I can start joining my component at this point. Click, move up to that point. Just have a single click, then move towards the diode. Click once you reach at the diode. Come to the other side, click, start the line again. When you reach there, click, then come down, click, then come to this other side of the resistor, click. When you want to take a corner, single click. I want to take a corner and go up, click. Once I reach there, click. And my circuit is wired, except I need to have one more component placed, and that is ground. Need to put in ground, and ground kind of tells me which is my zero volt point. So I pick my ground. Oh, sorry. So zooming in and zooming out, you need to use a mouse. Of course, there is an icon for zooming in and out, but a mouse wheel is very convenient. So now I need to pick and ground, place it there. So I can either place it like that, but just to illustrate it is ground, let me just place it there, pick a wire, that, zoom and bait. Yeah. So so now I want to believe you are following. So the next thing I want to do, remember all these components I have placed, I haven't put figures to those components, like resistor. What is the resistance? What type of diode? What type of voltage source? So I need to specify the parameters of each component. So the way I do is, again, I bring the cursor near the component. Like now I am near the resistor. I am near the resistor. And so once I get near the resistor, you see the mouse cursor changes and becomes a pointer. So all I need to do is right click the mouse. And once I right click the mouse, it gives me an option where I can key in the value of that resistor. So if I wanted this resistor to be in ohms, I just need to key in the figure like 100, and that will mean 100 ohms. But if I want to make it 100 kilo ohms, then I have to append a K, a capital K, or a case letter after after the value. If it's mega ohms, I need to append a capital M after the value. So in this case, let's have 10 kilo ohm. So I just write 10, then K. So now my resistor is 10 kilo ohms. Now let me specify my voltage source. What kind of voltage source is this? Is this a DC voltage source or a AC voltage source? Now, you know a rectifier converts AC to DC. So the voltage source here has to be AC, which we want to convert to DC. So when I hover over the voltage source symbol, what do I get? I get that window popping up, get a pop-up window like that, and I hope you can see it. If you can't, please let me know. So now, the default is a DC voltage source, but we want a AC voltage source. So I go to advanced option. So I have to click the advanced option like that. And now on my left hand side, there are more options to choose from, and I'm going to choose the sign. If you can see my cursor, I'm going to choose this option. So when I choose that option, I get more text boxes popping up. I need to specify what is the DC offset, and for that I will say it is 0. I need to specify the amplitude. You can put whichever amplitude you think your AC will give you. So let's, for purposes of this discussion, put 5, meaning 5 volts. And the frequency, let's put 50, because the standard frequency of AC means is 50 hertz in Kenya. So those are the things you need to specify for now. So say okay. Great. So now your voltage source and your resistor are specified. You can go ahead and again specify the diode. This one you can or you cannot. If you wanted, you can specify the exact model of the diode that you are going to use. So let's say, for example, we take the Rust model, because it's quite a common model that we use. So we pick that one, but you can even leave the default settings and it will work. So everything is specified now. So that is the circuit. Now let's try to simulate now the circuit behavior. So how do you do that? So now for simulation, you need to come to this menu, this option called simulate. Click at it and come down to configure analysis. And then specify the stop time. So for this kind of analysis, you can experiment with different values and see the effect. But for this case, I put 50 milliseconds. In other words, it runs for 50 milliseconds, then it stops. So then say okay. All right, so I'm ready to run the simulation now. And how do I run the simulation? So I come to this green button in this icon bar. So when you hover over it, you'll see run. So if I just click, I see a simulation window pop up, the black simulation window. So now, how do I simulate the result? Now, note my cursor. If you can see my cursor, when when I am near a certain net or path of the circuit, it gives me a probe, a voltage probe. The end thing is a probe to measure the voltage. So if I click, so for example, if I click there, if you can see, you are able to see a AC waveform that has been printed in my simulation window. And you can see it has the scale. And so the vertical axis is the voltage and the horizontal axis is the time axis. And you can see the time axis, my waveform stops at 50 milliseconds. And that 50 milliseconds is what I keyed in when I was setting up the simulation parameters. Needless to say, you can determine the time for one complete oscillation. That's what we call the period. You can, yeah. But that's the input signal. That's the input signal, which is AC in nature. Now, what is the rectified signal? So the rectified signal is I get the rectified voltage after the diode. So should I place now my voltage probe at this side? I will get the voltage after the current has been rectified, and let me do that. And you can see now, you can see the blue waveform is the rectified voltage, and the green waveform is the input voltage. And for sure, the blue waveform is rectified because only the positive half cycles pass through, and the negative part of the voltage waveform is blocked. And that is what we call rectification. I don't know, so far so good. Are you following? So I can see 6 members. Are you following? Can someone like say whether we are together or you? Are you seeing the waveform? Are you seeing what I'm doing? Chariot, are you following?
Yes.
Thank you. So so far we've been able to simulate a half wave rectifier. Now you know there's something you know we can still do with this rectifier. We can put a capacitor across the resistor just to make that waveform a little bit smoother. So let's try to put a filtering capacitor there and see how the waveform changes. Basically, what it does is we try to improve the output, because ideally you would want a constant output voltage, one that is not fluctuating. And so one scheme that is employed is to put a filtering capacitor across the road. And let's try to do that. So I pick my capacitor from the list there, come with it and then drop it there. I escape, take the wire. I think I should zoom in a bit, or maybe yeah, it's okay. So I've put, so that's the way you put a filtering capacitor. So what we just now need to do is specify the value of this capacitor. So I hover over the capacitor symbol and right click. And once I right click, I am able to key in the value of the capacitance. So let me put 1000 microfarad. So I type a small u after 1000 to mean 1000 microfarad. So that's quite a big capacitor that can do a bit of filtering. So I say okay. Now, let me try to simulate to learn the waveform now. I think let me restart it. So we run the simulation. So you see now look at the waveform. The waveform is, of course, the starting point, the waveform lies is, but then it's more or less constant. It's more or less a constant voltage thanks to the capacitor that I have introduced. So you have more or less 4.4 volts thanks to the capacitor. So yeah, so that's half wave rectification. That's half wave rectification. So let's jump to the PowerPoint again and see. So I stop sharing, then share the PowerPoint. Okay, so now we've designed a half wave rectification circuit and simulated its behavior. Now let's try to design a full wave rectifier. This is a circuit we call bridge rectifier. I want to believe at some point you have come across this circuit in your electronics. So we can try to build this, but okay, I will build it, but not exact without the transform, because what you can see you have the AC source, your voltage, AC voltage source. Then here you have the fuse. The fuse is basically to protect over current. So when there's a current surge, the fuse blows off and protects the circuit. Then here you have the transformer. This is basically a step down transformer because you have 240 mains. You want to step it down before you can do rectification. And then you have the rectifier circuit made of four diodes connected in a fashion we call back to back. So this is the rectifier. Actually, the rectifier is this network of four diodes connected back to back, and now you have your own resistor there. So the way this circuit works is as shown. So during the half positive cycle, like where you are seeing my cursor being, so that is when the AC signal is executing its positive execution. What happens is two diodes become forward biased, and the two diodes that become forward biased is D1 and D2, the ones in green. So D1 and D2 become forward biased, and at the same time, D3 and D4 becomes reverse biased. And therefore, the path of this current is as shown. So current would flow from, so what is shown is the electron, is the flow of electron, but current, the convention current flows opposite to the electron direction. So if we are talking of convention current, basically reverse the direction shown, and you'll see how current is flowing. So it could start from this way through the forward bias diode, through the resistor, then from the resistor. So this ground and this ground are connected, so they are the same point. So from the resistor again through this diode and back to the transformer. Now, during the negative half cycle, so this is the second diagram. Now, the diodes which were forward biased reverses, and the ones which were reverse biased becomes forward biased. That is to say, D1 and D2 becomes reverse biased, and D3 and D4 becomes forward biased. So that now current flows from so it goes this way. So current starts from the transformer through the reverse bias, through D3, which is forward biased, to the ground, and from the ground through the round resistor and back to D4 and again to the transformer like that. So that is how current would flow. Now, so essentially, what you end up with is voltage waveforms that looks more or less like shown here. So in either positive half waveform or negative half waveform, current flows through the rod. So you have current flowing through the rod, and therefore there is a voltage developed. So it's not like in our previous case where during one half cycle there is no current flowing. In this case, in both iterations, both positive and negative, current flows. And so let's try to build this circuit. Let's try to build this circuit. So I switch to my LT spice. And I will open a new project, new schematic, and I will arrange my dions. I will start by creating the dions. Um, so I choose the diode, choose the diode here. Where is the diode? The diode is here. So my first diode, I want it look look like that. And my second diode, I want it to look like that. My third diode, because we are connecting these things back to back. So I've placed my diodes. Maybe what I can do now is join the diodes with a wire. So I've put my diodes back to back. Basically, that arrangement is what is referred to as back to back. Um, uh, Occasionally, your thing will then disappear, so you want to move it where you can get a good view. Now, the next thing I want to put is the round resistor, the round appliance. If you can remember, it was put somewhere uh, there. Now, allow me to move it a little bit. Let me put it far away a little bit. Okay, escape. Now connect the round resistor. If you can follow, trying to build a bridge rectifier. So the next thing is to put the voltage source. Now I won't put a transformer. What I will do is I will give you the assignment to put the transformer yourself. What I will do is I will introduce a AC signal directory. So if you are following, I think we have built our bridge rectifier. What remains now is to specify the component parameters. So let's start with this resistor. Right click and put the value. I'll put 10K. I won't specify the diodes because the default is still okay. But I will specify the voltage source. Go to advanced. Sign offset is 0. Amplitude, I'll make it 12. Frequency 50 hertz. And that's it. Now I go to simulation and set the configuration. Basically to tell it to simulate for 50 milliseconds. And then I run the simulation. So I need to, so this is like the command that tells it that the simulation is to be ran for 50 milliseconds. So I believe you can see the circuit. Now let's simulate. So there are several figures. Let me cross some. So this is, I believe, this is the thing. Yeah, this is our circuit. So let's first of all see the voltage input. Now, there's a problem there. The input, I would have expected to see an input that is a sinusoidal, but this one is not. So maybe what I do is, let's see. Still, I'm getting issues. Let me try to remove this ground thing. And so let me connect with the wire between those points. So I seem to be having a problem because I would expect the input waveform to be sinusoidal. It's not. Maybe I need to do something. I need to specify the diodes. Maybe I should have, because that's the step I didn't, I skipped. Maybe that is what is causing the issue. So I pick this diode because it's a common diode. Pick a diode. Okay, so bando tujafua ndafu. So maybe I need to check need to check this voltage. Oops, okay. Mhm. So for some reason, I'm not able to get a good input waveform. Um, what I will request you is to practice what I have done. Then let me try to find out where the problem is. and then I will come back. So what you can do is please feel free to practice what I've been doing, and then maybe the remaining bit of it I'll send a recorded video of what I'm doing once I figure out where the error is.